In this video, I'm going to illustrate the concepts behind half-life. So let's say you've got a collection of atoms, and a collection of atoms create, let's say this block of matter here, it will create a block of matter which is 100 kilograms. You're going to have to forgive my science on this. A half-life of 5 means after a period of 5, let's say hours or years or decades, whatever, the block of matter will lose half of its mass, so it would now be 50 kilograms. And another 5 hours later, or 5 years or 5 decades or whatever, then it will lose another half of its mass. Somehow the atom dies or gets emitted. I don't know, you have to ask your science teacher on this, but the concept behind a half-life is that after this period of time it loses half of its whatever, its mass, its whatever. You're going to have to speak to your science teacher. So let me illustrate this, hang on. So let's say our block is currently 100 kilograms. A half-life of 5 hours, say, it means that it loses half of its mass, so now it's at 50, and then another 5 hours later it would be 25 kilograms, so this is at 25, and another 5 hours later it would be 12.5 kilograms. But then what happens when you want to know somewhere around here, let's say after 8 hours, what will be the mass? So we need a formula for this, y equals whatever here. We've got to develop this whatever. Okay, so hang on. So let's start out with e to the power of x. We know it looks like this, and remember, if I were to give you f of x equals x squared, it would look like this. And then if I were to apply this transformation, it will make it steeper. And we've done this, so I'm expecting you to know this. And if this number is less than 1, then it would be wider like this. And I'm expecting you to know this. So so for us to come up with a formula for this this graph here, we need to start out with e to the power of x. We need to start out with e to the power of x, and then we need to apply this transformation. So we start out with f of x equals e to the power of x. Apply this transformation, that will then give you this. We have no idea what this looks like, but we do understand this transformation. This transformation will flip it along the y-axis, so now it looks like this at a height of 1. So applying this transformation will give us this graph, and then currently it's at 1. If you put 0 into here, then this will be e to the power of 0. E to the power of 0 is 1, so that's why it jumps to 1. But then if you want a height of 100, then stick a 100. Well, stick 100 in front of it. So that would now, instead of being 1 down here, it would be at 100. So now we are currently here, and now to move the to create this thing after 5 hours, we want it to be at 50. So we need to stick some sort of constant, because remember, if you remember this thing, f of x equals x squared. And then if you apply this transformation, fk of x, so that will then give you this. This k here will make it wider, or it will make it steeper. So we have the abilities to squash it or to stretch it. So we need to somehow stick this k in here. We've got to establish this k. So to create this k, put 5, after 5 hours, put it into here. So that will then give us this. After 5 hours, we want to force a graph to be at 50. So we put the 50 into here. So now it's just a matter of working out this constant k here. So we force this condition upon our equation. So that will then take us to here. Now work backwards to find this constant k. So now divide both sides by 100. That will then give us a half equals this. And then take the natural log. Hang on, let me think. We are currently here. Now take the natural log of both sides. So that will then give us this. And then on the right hand side, remember, whenever you log an e, they cancel each other out, giving you negative 5k. And remember, log of a over b, that's the same as log of a, take away log of b. So a half would be log of the top and then log of the bottom. Well, natural log of 1, remember the natural log graph looks like this. This is 1. Natural log of 1 is actually 0. So that will then give us this. Times both sides by -1. So that will then give us this. We want k on its own, so divide both sides by 5. That will then give us this. You can, if you want to, push this back up here. So it looks like this, if you want to. So that's like the 5th root of 2, if you want to. Well, we're just going to leave it as this. So that will then give us this. That will then give us this. So now if you punch this into decimals, say, it will then give you this graph. So punch this into decimals, and then it will give you this graph. So a half-life of, let's say, 5 hours, it means this. After 5 hours, you're now at 50 kilograms. And then another 5 hours later, you're precisely at 25, and so on. So it halves every 5 hours. And by the way, you don't have to start counting at time equals 0. You can jump in and count at 2 hours. Alright, let's say 2 hours is here. Then 5 hours later, which would be at 7, 5 hours later, this should be exactly half of this. So you don't have to start counting at 0. You can jump to, I don't know, let's say 6. So currently 6 is here. 5 hours later, which will be 11. This will be half of this. So that's what is meant by a half-life of 5 hours or years or decades or whatever. Okay.